Hello everyone. So today we will look at a few lead code questions which will be of easy level. So the first question will be to find a reverse of an given integer. The second one will be to find whether a given number can be expressed as a power of 2 or not. And the third one will be to find the complement of a base 10 integer. Okay. So let's start with first question, that is to reverse an integer. Okay. So what is given in the question? Given a signed 32-bit integer x, return x with its digit reversed. Okay, 32-bit integer x will be given to us and we need to reverse its digits and return. If reversing x causes value to go outside the signed 32-bit integer, then return 0. Okay, means a value will be given to us which will be in the range provided by them, as well as the range assigned to the integer, it will be in that itself. But while reversing, if that value exceeds the maximum and minimum value supported by the integer, then we need to return 0. Okay, so the question given is clear. If 123 is given, we need to return 321. If minus 123 is given, we need to return minus 321. If 120 is given, we need to return 21. Okay, so the question is very clear to us. So as we need to reverse it, what first thought is coming in my mind is we can find the last digit. Okay, and then after finding the last digit, I can multiply that last digit by 10 and then add the previous number and then keep on multiplying it by 10 and then again adding the previous numbers. Then this way I can get what I want. Okay, um, so let's see. Um, First of all, I am initializing the answer which I want to return as 0. Then I'm running the loop until the given number is not equal to 0. Then, as I said, I am finding the remainder, that is the last digit of the given number, which we can find by modulo dividing that number by 10. We will get the last digit. After we get the last digit, um, we can do this step here or we can do anywhere, doesn't mind. So now only I am dividing that number by 10 because we already got the last digit and we now don't need it anymore, and we have already stored it into the variable known as rem. Okay, so we are dividing that number by 10 so that we get the latest last digit. Okay, this we will see later, this condition. Okay, so after I got the remainder, what I am doing is um whichever will be my answer, whichever will be my previous answer, I need that answer with me, multiply it by 10 and get the latest last digit. Okay, so if the integer is 123, okay, and the latest last digit which I got is 3. Okay, so initially the answer should be 0, which I have initialized here, and if I multiply this answer by 10, and the answer it will be 0 and the remainder will be 3, so in the answer 3 will get stored. Okay, so now in the answer I have 3. Next time the last digit will be 2. Okay, so when 3 into 10, that is 30, will be added by 2, I will get 32. Now 32 when multiplied by 10, I'll get 320, and when the remainder is 1, I'll get 321. The answer is reversed and we can return that particular answer. Okay, so this is about it. Mm, this is how we reverse the number. Okay. Uh, okay, and what about this statement? This statement, we need to add this statement so that it does not exceed the int max value. Okay, the maximum value which integer can hold, uh, So a particular variable, integer variable, can hold only that much value, maximum int max value it can hold, not more than it. If we force it to hold some value which is greater than int max, then it will throw an error. So we need to take care of this condition. So this is the statement which would be causing error. So if in the previous iteration, um, if we multiply the answer by 10 and add the remainder to it, and it is very close to int max, and when we again in the next iteration multiply it by 10, there are chances that it can um, go beyond the int max value and the variable could not store it and throw an error. So to handle this error, we will beforehand add this condition that if the answer is greater than int max by 10. Okay, so before executing this only, what this statement says that is, if answer into 10 is greater than int max, which we are going to do, answer into 10 we are going to do just after this. So we are checking it before only. If answer into 10 is greater than int max, or if answer into 10 is less than int max, then we will simply return 0, um, because it is already mentioned in the question that while reversing, if we get any integer which does not falls into the range of integers, then we have to return 0. Then that's why we are doing it over here. Answer into 10, why we have not written, because answer into 10 have to be again stored in a variable which cannot be stored. Okay, so and int max by 10 can be stored. So answer into 10 greater than int max, we can also write, if when we divide both side by 10, we can write answer is greater than int max by 10. Okay, and same goes with answer is less than int min by 10. Okay, so we are beforehand checking it and immediately returning 0 if this condition, any of these condition is getting true. We are immediately returning a 0. If it is not getting true, we are executing the statement and then again moving up, and we will keep on doing it until the given number is still greater than 0. Okay, we'll keep on doing it. So this is about the code of reverse integer. Let's run this code. Okay, all our test cases are passed. Now let's submit it. We are getting the right solution over here. Okay, all our test cases are passed and we are getting the correct solution. Okay, I've solved it multiple times over here. I'm also following code help channel, so these all questions are same. Just I'm using a few of my own solved methods, and if I don't know, I'm taking help from code help channel. Okay, so now let's see the second question, that is to find the whether a number can be uh, expressed as power of 2 or not. Okay, so there are various methods which I have tried and then I'm making a video on it. The first method would be to find the power of 2, and I'll apply a loop which would run from 0 and continue until I get the value which is equal to n. Okay, so I'll continuously find the power of 2's until that power is less than or equal to n. I'll keep on incrementing that loop. Okay, so 2 raised to 0, 2 raised to 1, 2 raised to 2. I'll keep on doing this until that value is less than or equal to n. Okay, and once that value exceeds n, I'll come out of the loop and check whether that particular value is equal to n. Then it got out of the loop, or um, has it exceeded that. Okay, so I'll check it over here. Yeah, here I have written I minus 1 because after entering the loop, when 2 raised to when it was 2 raised to I, it has returned n. Okay, it has entered this loop and now it has become I plus 1. Okay, so to reduce that I plus 1, for 2 raised to I, it might have been equal to n. Okay, uh, and so it entered the loop and I became I plus 1. Now I have to check whether uh, 2 raised to I minus 1 was equal to n or not. If it is equal to n, then we will return true, that we found that this number can be represented as power of 2, and if not, we can simply return false. Okay, this was first method. Now let's look at second method. As we know that the range of integers as mentioned here is minus 2 raised to 31 to 2 raised to 31 minus 1. Okay, so the positive range, if we see, it is less than 2 raised to 31. Okay, so we need to go from zeros to 30 only. Okay, no need to find for 2 raised to 31 because it is minus 1 over here. Okay, so that's why I have applied a loop from starting from 0 I0 to I less than equal to 30, and every time I'm comparing the answer, uh, whether the answer is equal to n or not, given number or not. Answer initially I have initialized it as 1. Okay, so in first iteration 2 raised to 0 is 1. So here also in first iteration it will work if the answer is equal to n. If 1 is equal to 1, obviously 1 can also be expressed as power of 2 as 2 raised to 0. So this will get true if the n is 1 and it will get returned. Okay, and if it is any number which is greater than 1, this condition will be executed and we will multiply the answer by 2 and keep on doing it until we get until I is less than equal to 30, or until I is less than or equal to 30, or we get answer is equal to n. Okay, once all of the loop is executed from 0 to 30 and we come out of the loop, when we are coming out of the loop, this means that we didn't find any number which can be expressed as power of 2 because we have checked um, all of the powers and we cannot find that number matching with any of the powers, so we can simply return false. Okay, and here also same like last condition we have put, because we are multiplying the answer by 2, and if the answer is very near to int max, in the next iteration there are chances that it would surpass the int max range. Okay, so we are beforehand applying this statement. For multiplication it is very important because we gradually increase the size, we uh, rapidly increase the size over here. So this condition is very important to be addressed over here. Okay, this is all about the second method. Now let's see about the third method, in which I am counting the number of ones in the binary representation of the given number. If the number of ones is exactly 1, then we can say that that particular number can be represented as a power of 2. Okay, if it is number of ones is 0 or the number of ones is greater than 1, then that number cannot be represented as power of 2. Okay, so this is the logic behind it. For example, 8 8 can be represented as 1000. Okay, yeah, 4 can be represented as 100. 2 can be represented as 10. In all these examples you can see that only one time a 1 has appeared over there. Okay, only once the 1 has been appearing. Okay, so I am finding the last bit n and 1 by doing n and 1. I will find the last bit and store it into variable rem and then right shifting it. Now I will check whether the last bit which I got is equal to 1 or not. If it is equal to 1, then I'll increment the count. After incrementing the count, I'll check whether this count is exceeding the value of 1 or what. If it is exceeding 1, then I'll simply return false because we just want count as 1. Okay, if the count is 0, this won't be executed, and the next iteration will run by we have already incremented the value of n, and the next iteration will be running. Okay, so this will run until the value of count is less than or equal to 1. If it exceeds 1, we will simply return false. After coming out of the loop, we need to check whether um, the count is 0 or the count is 1, because if it is greater than 1, we are simply returning false, and if it is coming out of the loop, this simply means that there are just two chances, whether the count is 0 or whether the count is 1. Now if the count is 1, we will return true, or else we have already returned false over here. Okay, uh, this return null is nothing. The compiler wanted this to have some return value, that's why I've written over here, or else in a VS Code we don't need to write this. Okay, so now let's run this code. I've already run it many times, solved many methods, and finally I'm making a video on it. So the solution is accepted. Yeah, so we have solved this question also. Now let's move to finding complement of a base 10 number. Mm, So finding complement simply means that if the bits, we need to reverse the bits. If it is 0, we need to reverse it to 1. If it is 1, we need to reverse it to 0. Okay, so um, let's see an example. If 5 is given to us, we need to find its binary representation, that is 101. Okay, now 101 we need to reverse it, complement it. 101 will be 010. Now 010 will be 2 in decimal, and we need to output 2 over here. Okay, so this is the condition which we need to follow. Now let's see how we can solve this. Okay, so let's see, as it is a base 10 integer. Okay, so that base 10 integer, um, first I need to find its binary representation. Okay, and after finding its binary representation, I need to reverse it. After reversing it, I need to again convert it back to decimal form and then display it. Okay, so this is a very lengthy process. So what I have done is, I've initialized the answer as 0, and I've taken an increment variable I to increment through the loop. Okay, I'll run this loop until the given number is greater than 0, and uh, n and 1. Okay, n and 1 will give me the last bit of that given number. If I'm getting the last bit as 0, I am entering into the if condition. Okay, I'll tell you why. Because if I'm getting the last bit as 0, I need to convert that 0 into 1. Okay, I need to convert that 0 into 1. Um and if I get a last bit as 1, that is of no use to me, because that 1 will eventually become 0 after the complement, and that 0, when I'm trying to convert that particular bit into decimal, then that computation will have no value. Okay, because 0 into any power of 2 will be 0 itself. Okay, so I am bypassing all those conditions, and directly I am here I am finding the bits which are representing 0 in the original given number. Okay, if in the original given number the last bit which I am finding is 0, okay, I know that after complementing, that particular bit will become 1. Okay, so that particular bit will be becoming 1, and so I am directly multiplying sorry raising 2 with a power, and then adding it to the answer, and that I will decide which bit is that. If it is 0th bit, I already have I as 0. If the first bit is only 1, if the first bit is 0, that is bound to be 1 after complement. Okay, so it will be 2 raised to 0 plus answer is 0, that is 1. 1 will get stored in answer. Okay, so we are finding the bit also of that number. We are even complementing it also, and as well as we are converting it also in this small statement itself. Okay, and in every iteration we are incrementing the power, we are incrementing the value of I, whether it is whether the last bit is 0 or 1, we don't care. We are just incrementing it so that we could uh, raise that particular value of I to uh, 2 2 raised to that particular value whenever the complement which whenever we are getting the last bit as 0, because it will be eventually converted into 1, and so for that we need the power of 2 which has to be added to the answer. Okay, so and as we have to return the answer in decimal, we need to convert it into decimal. Okay, and we are then right shifting the number by 1. Okay, right shifting the number means dividing the number by 2. Okay, we are dividing the number by 2 so that we will get the latest last digit. After getting the latest last digit, we are again finding its bit, that is only the last digit. Okay, we are again comparing whether it is 0 or 1. If it is 0, we know that it will be converted into 1 after we take a complement, so we are taking the power of that uh, we are taking the power of 2 and then adding it to the answer. And we are incrementing I, value of I will say what we need to raise to 2. Okay, so in this way we are solving this question to find the complement of base 10 number. Now let us run this code and see what's the output. All the cases are right. Now we will just submit it and see what is the answer. Okay, so we have solved it, and the value is accepted. Now let's see the other solution also. uh, this is the solution which I have seen in the code help channel, and this is the very good solution, and learned a lot from this. Actually what he did is he took a mask, uh, a variable mask, and stored 0 into it, and there is a complement variable like this. If we do complement, then we will get if it is 101, we will directly get 010. But when we complement a number, uh, we will even get the if it is 101, there will be zeros towards the left of it. If it is 32-bit number, then there will be 29 zeros before in at the start, and then at the last I'll have 101. Okay, so after complementing it, I'll get 29 ones, and after that I'll get 010. So I just want that 010, and the answer of 5 complemented should be 2. Okay, so I need to neglect those extra 29 ones which I got at the left hand side. So for that I am making a mask. So what a mask will constitute is it will constitute of all the ones which will be there, and these number of ones will be we will have that much number of ones which represent the number 5 rather than all the um, exceeding zeros. Okay, so we will apply a while loop and check whether the number is 0 or not. Until and unless the number is not 0, we'll continue doing it. We will right shift the number by 1. After right shifting the number by 1, okay, we are right shifting the number by 1, and we are taking the mask. As we know, earlier the mask is 0, and after and I am left shifting the mask, and after left shifting the mask, 0 left shifting mask will be 0 itself. Now 0 will be OR with 1. After a OR the mask with 1, I'll get 1. Okay, because anything OR with 1 is 1. Okay, this is bitwise OR. Okay, so in first iteration I got mask as 1. After I got mask as 1, I'll move to the next iteration, and again I'll right shift the number by 1. After right shifting the number by 1, and still the number is less, I'll again increment the mask, again left shift the mask by 1, and then again OR it with 1. uh, in this way I'll get two ones. If there are three numbers, that is 101, then again it will check. Again I'll get n not equal to 0. Again the mask will be left shifted by 1. Again I'll or that left shifting means I'll get 0 to the towards the right hand side. That 0 I need to OR with 1, so I'll again get a 1. So I'll get three ones for 101, and after getting it, um I need to I need to store that mask. Okay, after coming out of the loop I have the mask as triple ones. Okay, so this is of no need actually. Okay, so this is fixed. It is of, oh, what has happened, and what to base to, what is this? Okay, so yeah, I have the mask with me. I'll complement the given number. I'll of a 101, I'll have all the ones at the start, then 010 afterwards. And when I AND it with mask, I'll have all the zeros, 29 0 at the start, and then 111 at the end. Okay, so all the zeros will become zeros, and all the ones will take the value of last three bits of k, which we wanted. Okay, we just wanted the last three bits of k. We wanted the last three bits of inverse of k, that is a complement of k, which we are getting. Okay, and as we are performing bitwise operation over here, that binary number will be converted to the integer as we want, as we are storing it into an integer value answer. So if any binary number is there, we are storing it into integer, so it will be converted into integer and stored in the variable answer, and then that value will be returned. Okay, so in this way, this um, function will be working. This is also an important concept. I learned a lot from this. Uh, so thanks to his channel. So that's all about this. That's all about today's video. Thanks for watching. If you have any doubts, do let me ask in the comment section. Uh, by doing so, you will also learn a lot, and I am also learning a lot. Mm, so that's it for today. Thanks for watching, and bye bye.